of you that have a book or an outline, you need to get that out, because I'm going to pull it up and I'm going to show you what I'm not going to cover. I want to say that logarithms is chapter 4. Is that right? 3.
Yeah.
I thought it was chapter 4.
Yes.
Okay.
The handout says 5, 1, 2, 5.
Yeah, I thought it was. Now we just covered 4.
4 is logarithmic functions.
All right.
The basic logs is 3.
Yeah, 5.1 and 5.2 is what I don't cover. Let's look at it and I'll show you why. I don't cover it because you can do everything on your handy dandy calculator. And it's kind of like, Mr. Harvell can relate to this, but some of the older students can. Back a long time ago, before the calculator, you had to find the trigonometric functions out of the tables. They'd have a table in the back of the book with all the trig functions. And then, of course, when the calculators came along, you didn't use trig functions, you didn't use the tables, you used the calculator. So they quit covering the trig tables in the math class, in the trig class. They quit covering. Well, now you can't even find them in the daggone book. They don't even use them anymore. Well, in this section, you cover some functions in 5.1, the inverse operations, and they're about impossible to plot using points. You can, they're very tedious. So what I tell students to do is just make sure you can plot them on the calculator. And I'll show you in just a second what I'm talking about. Horizontal line test. If you want to check to see if it's a one-to-one function, do a horizontal line test. That'll tell you if it's a one-to-one function. Okay, that's. Hold on, and I'll get to the point that I'm getting to. Just give me a second.
1, which will stop you from even doing the problem if it fails.
Yep. All right, now this is a deciding whether two functions are inverses. Now we talked a little bit about inverses, and we talked a little bit about how to find the inverse of one, and I'll just show you, let me reiterate how to do that.
Are you presenting the screen yet?
Oh, it's not presenting?
Not for me.
Okay. Mr. Harvey, do you remember any of this?
Yeah.
Let's see, where's my calculator? Hold on a second. My back is killing me today, so. Oh, Lord. Thank you, Mr. Strickland, for speaking up.
You're welcome. You're welcome.
All right. Let's see if that does better. Okay. Get to. Okay. Remember when I told you if you're given a function? Let's use this function right here. And I told you f of x is equal to x cubed minus 1. And I told you to make this y is equal to x cubed minus 1. And then I told you to do what with the x and the y? Interchange them. So x is equal to what? Y cubed minus 1, and solve for what? Solve for y. So bring that over. X plus 1 is equal to y cubed. And take the cube root of x plus 1. And that is the inverse function of this. Y'all remember me telling y'all how to do that? I did that at the end of chapter 3, I think. Y'all remember? Or chapter 2. It was the end of the two tests together. Remember the two tests together? It was the end of the second test. I showed y'all how to do that. Well, they're just confirming that right here. Okay, if you do G composed of F and F composed of G, that's what they're saying. I'm not going to test you on that, but if you plug in and then you plug them in, so if F composed of G, F is this, so that means you're going to put a big set of parentheses, minus 1, and then what you plug in to F composed of G, what gets plugged in? G, yeah, cube root of x plus 1, and that cancels that out. And what's x plus 1 minus 1? And you should get the same thing over here. So let's do G composed of F. So G composed of F, G, need to rewrite G with a big set of parentheses, cube root, parentheses, plus 1. And then F gets plugged into it. F is x cubed minus 1. And what is x cubed minus 1 plus 1? Well, minus 1 and plus 1 cancel. And what is the cube root of x cubed? So their inverses of each other. So that's the way you can check it algebraically. If they equal the same thing, then they are. And this is algebraically. This is not graphically. Graphically is when you just plot them, and that's what I'm going to let you do on the calculator. All right. So that's that. Mr. Strickland, everything showing up okay?
Yes, sir. Yes, sir.
Yeah, I guess. He's not talking to me.
Yes, sir. My mic has been muted. Then I have to watch it when I talk.
There's what I just showed you. So write that down, page 339. That you will be tested on. Right there. Which I just showed you. Let's say here's where you can, here's two right here. Find the inverse of the function with a restricted domain, all right? Find the inverse of this function right here. Do it with your algebra that you just learned. So that's going to be f of x is equal to the square root of x plus 5. So y is equal to the square root of x plus 5. So x is equal to the square root of y plus 5. How do you get rid of a square root? Square it on both sides. X squared is equal to y plus 5. Y is equal to what? X squared minus 5. So that is the inverse function of that function. But the domain is all real numbers on this one, but what's the domain of this one? Well, you can't take the square root of what? It's a negative number. X minus 5 is equal to 0. X cannot equal some part of 5. Okay? 5, you can equal 5, but it's got to be greater than or less than. So, because you can take the square root of 0. So, what if you plug in a 6? It would be a 1. If you plug in an 11. What if you plug in a 7? 7 would be 12. What if you plug in an 8? It'll be negative 5 or plus 5. Negative 5. Oops, negative 5. So what about negative 4? Negative 4 plus 5, negative. So we can use all numbers greater than what? Greater than or equal to negative 5. So we're going to have to do that down here too, because these two are opposite or inverses of each other, we can't use negative 10 with this one, so we can't use it with this one. See what I'm saying? So x is greater than negative 5, and that is your graphical representation. Now take your graphing calculator and now graph the two. Notice I said take out your graphing calculator because you need it. That's when you use the graphing calculator, not to take the square root of 25. And we hit graph, y is equal, and I'm going to do the actual function, square root of x plus 5, alpha, or just x, plus 5, close parentheses, and then in darker colors, I'm going to do y is equal to x squared minus 5. X squared minus 5. Graph. There's your square root function, and there's the other function. But you cut it off right here because these are the inverses of each other. These two are the inverses of each other. It's easier to see here because they've got it. They don't have the graduations. It's but good. So what you need to do is go to Windows and maybe set the, let's go with negative 10 and positive 10. That shows it a little bit better. And then you can do y is equal to x, and I'll do this in some kind of, where's the little, there. And y is equal to x because that is your oblique. I can't find x, is it? Anyway. Now you can see the actual, okay? You can see the actual symmetry around the oblique axis right here. That's where it intersects, just like right here. And then here, negative 5 goes up, and negative 5 here. Okay? So, even though it's hard to see because you got this right here, it's easier to see with this drawing here. Now, it's not that big of a deal. Make sure you can graph it, make sure you can do it algebraically. But you're only talking about 20% of your test. Well, 20%. Did I give y'all a unit? Did I give y'all chapter 4 test? Okay. Chapter 5 test, you're only talking about 20% of your test here. And one question is going to be a graphing on the calculator, and the other one's going to be doing it algebraically. Okay? So that's pretty much going to take 5.1 and 5.2. All right? Finding the inverse of a rational function. Again, go ahead and let's do that. Find the inverse. F of x is equal to 2x over x minus 1. And what do? This is y is equal to 2x over x minus 1. Now what? X is equal to 2y over y minus 1. Now the first thing I'm going to do is multiply both sides by y minus 1, right? And that's going to give me x times y minus 1 is equal to 2y. And now I'm going to, I think that's where we are right here. And I'm going to distribute this because there's really nothing I can do but distribute. Xy minus x is equal to 2y. And then I'm going to take my y's and put them on one side. So, yeah, I want to get y by itself. Negative x is equal to 2y minus xy. And then negative x is equal to y. And that's 2 minus x, right? And then divide by 2 minus x. So that should be negative x, and what they did is they just multiplied by negative 1 over negative 1 to get it to look better. That's the actual function. Negative x over 2 minus x. Y is equal to negative x over 2 minus x. And what they do, they just multiplied by negative 1 over negative 1. And that gave them x over x minus what? 2? Yes. So that's the answer, as well as this is the answer. Both of them are the same thing. Now, graph the function, 2x over x minus 1, and then graph that function, and you should see the symmetry. And that's what you're doing in 5.1 and 5.2. So let's graph it. Where's my calculator? Okay, I don't want to see that. I want to pull it over here. There we go. Alright. Y is equal to, the first function is 2x over x minus 1. 2x divided by, parentheses, x minus 1. And then the second function is y is equal to x divided by, parentheses, x minus 2. And you can see it's symmetrical. I mean, you can pretty much see it's symmetrical. It's not around the x, around that one, but around a shifting y-axis. Everybody see that? It's symmetrical around, hold on, what is that? Y is equal to 2? Oh, I'm sorry, x is equal to 2, or, yeah, somewhere around here looks like it's symmetrical. I'll just put it right there. You can, right there where the arrow is around where it's symmetrical. I don't think they're going to ask that. No. They just ask, all you need to be able to do is algebraically do it, as well as graphically. And that's 5.1. Let's see what 5.2 is. I think 5.2 is a continuation. Yeah, exponential functions. Make sure you, okay, let's go ahead and pull something up that everybody should have. Now, this is one of those things where you Google something and you print it out and you keep it. Okay, it's a lot of work. I know it takes about 15 seconds to do it, so you know it's worth the long time period to do the work. I'm being facetious. Go to Google, and I want you to pull up exponential laws. And go to images. And just pick one. Sorry. Okay, I didn't need that. Go back. Get out of here. How do I get out of this? Oh, I hate it when this happens. There. Alright, let's do this. Let's save this. Save picture as. And
I can't see the screen.
Whatever. Save. And then pull up Logarithmic rules. I'll just go ahead and pull it up.
I can't see screen anymore.
If you wanted to change base, I'll just have to add the change base and also add the definition of the logarithm. Hold on 1 second. Logarithmic rules and definition of
Hubert, can you guys hear me? Whoa.
I'll throw them up separately. Let's do this one. So target. OG. And let me pull up definition of a logarithm. All right, so let's pull up handy dandy whiteboard. Okay, you need to write all these down because I doubt any of y'all will go home and print this out, because that would, include wool, work. So and put the logarithms over here beside it. Go ahead and write down those definitions right quick. And of course, like I said, it's easier just to go home and print out the logarithms on one page and then print the other ones on the back and have it in your notebook, and you'll have them there. I'll highlight the main ones over here. This right here is the product rule. This is the quotient rule. Product, quotient. This is the power rule. That's another version of the power rule. I don't know why they're showing that, but that's just extra.
We still can't see
the inverse rule. And that's good enough. And you see the power rule. So you see the same names are with the exponential laws as with the logarithmic rules. Why is that? Because a logarithm is a glorified what? Exponent. Exponent on steroids, exponent on vitamins, exponent, electrified, whatever you want to call it. That's what a logarithm is. It's another way to show growth. All right? Where do you see logarithmic growth the most in real life? Anybody want to take a stab at it? Good job. How did you know that? Oh my gosh. I've never heard anybody actually say microbiology. Environmental sciences. Anything having to do with environment. Why? Because you've got to find out problems having to do with algae or having to do with bacteria growing in an environmental setting. That
Mr. Hebert.
Logarithm. The only other operation is Indiana Jones. What?
Mr. Hebert.
What is Indiana Jones? He's an archaeologist, right? And what do you do with archaeologists when you find something? What do you got to do? Date. And that's where logarithms are also used there with carbon dating. And the only other place is, what did Hillary Clinton sell to the Russians? Even though they didn't report it. What was it? What was it? Uranium, right? Yeah, uranium. Having to deal with radioactivity. And that is half-life and dang old nuclear. That's where you see a lot of logarithms. So if you're heading into any of those sciences, how do you think of microbiology?
We can't see the screen.
Oh, so just take microbiology.
I think it does.
Yeah, it does. It's like having third semester calculus on a elementary ed major, you know. Yeah, I mean, yeah, that's good. As you ever seen a Goodwill Hunting?
I don't watch that movie.
Oh my God, that's a great movie. Anyway, there's a scene in the movie where the girl with the bad underbite, what's her name? Minnie Driver. She's got a bad underbite. Anyway, she's not that pretty, I don't think. But anyway, she, what? Yeah, Minnie Driver. The guy is gifted. He can do mathematics and science like people read, comic books. I mean, he can. And she's studying organic chemistry. And she's trying to study for a test, and they're sitting at this cafe, blah, blah, blah. And there she's studying. She says, it's important that I have to learn this. And she's got an English accent. And she says, well, let me help it. Let me get a little peek at it, and maybe I can help it. And she goes, like you study organic chemistry? Yeah, a little bit. Yeah, like in your spare time. Are you mad? And it's a funny part of the movie, but microbiology, you decided to take it, are you mad? And that's, anyway, it's funny. Yeah, I guess you have to watch the movie. Yes, sir. I'm sorry, I didn't hear you. This one right here, that is the inverse rule. Okay? Yeah, this one right here, oh, that's the definition of a logarithm. Great. I didn't see it when, no, that's not the definition of a logarithm. The definition of a logarithm, which you're going to get into, and we're going to spend, when y'all get back, we're going to spend a whole lot of time on, is, right, I thought I had it brought in, but I didn't see it. I hate it when it does that. There it is. There's the definition of logarithm. Write that one down, because that one, if I was to give you a test on logarithms, this right here would make up 50% of the test. Not only in how to rewrite a logarithm, but also on how to solve logarithmic equations. That one is very important.
Mr. Hebert.
Now, before we start on logarithms, I just want to go through a couple of exponentials just to see if you know what's going on. X to the 4th times 5. What is that? X to the 20th. We use power rules. This helps for your stuff. All right, let's do one that everybody misses, or some people miss. What's that one? 4x to the 8. Glad I'm refreshing. What's the most popular error right here? This is to the first power, and you got to distribute that 2 here And there. And that's why it's 4. Most, if I was to put that on a test of 20 people, 5 people would miss it. Okay? How about this one? X to the 4th times x to the 5th over x to the 9th. Why is it 1? You add the exponents, what do you get up top? You get x to the 9th. And then you use the quotient rule. What's 9 minus 9? And what's x to the 0 power? 1. And if you don't believe that, somewhere up there it says x to the 0 equals 1. So it kind of helps to refresh on some of this, and that's what you do in 5.2. And there's also a little bit of graphing with exponentials. Uh-oh, hold on a second. Miss Cherry get kicked out. Okay, y'all can't see the screen, or are those old? Those are probably. Y'all still can't see the screen? Hello, Skype people. I'm talking to y'all.
No, we can't see it.
No.
Okay, are they just dead or what? Okay, y'all can't see? Can't hear either. All right, hold on. I did present desktop. It didn't take it. How about now? Can you hear me? Can you hear me now? This stupid microphone cuts off. I'll just leave it on there. Okay. All right, can you see the screen? Okay. Don't know why. I did it when Mr. Strickland asked. I don't know why. I'll leave this on the board here for a second. Y'all can pull this up with Google. The left side, the pink and white, I pulled up with Google and I called it logarithmic rules. And the one on, exponential rules. The one on the right, I pulled up with logarithmic rules. And this right here is called the definition of a logarithm. Okay, so y'all take a second and take a picture of it on the screen or do a print screen or whatever and save this shot so you can have it. There we go. And then I did a couple of problems with the exponential laws. Sorry about that. Let's see if everybody else is okay now. Okay, everybody's fussing about that.
Properties and the definition.
Mm-hmm.
Not 359.
Okay.
3.
359 and what?
363.
363. So write that down if you want to get out of the book. 359
Yes.
and 363.
Yeah.
And that's exponentials and logs.
Yeah. Yeah, the two right pieces you guys do.
And somewhere in there, the definition of logarithm ought to be in there too.
That's on 359.
Okay, yeah. Okay, this one is oops, very important. In other words, if you don't know this definition right here, these up here are not going to help you because these feed off of this, especially when we get to the equations. Okay, Skype people, y'all okay now? Mr. Strickland, you're the spokesman for the Skype people, so read the messages and see if everybody's caught up. Everybody text?
Yes.
Okay, everybody's good? All right. So, I'm going to, I don't want to do this, but, yep, I figured that's going to happen. All right, so let me go back to the section. Nope. There we go. And real number exponents, that's where we're talking about additional properties of exponents. This is kind of a review for y'all. Okay, here we go. Example 1, 2 to the x. That's the family of graphs. Remember your family of graphs. 2 to the x looks like half of a volcano. All right? The difference between it and 1 over x is it doesn't have the second line. All right? The 1 over x has this and this. 2 to the x just has the left side. So you need to make a note of that. Not a big deal. Have 1/2 x, do it on the calculator, and you can do that. Then I'll take the calculator. Y is equal to, this thing gets on my nerves. Y is equal to, and just say 5 to the x power, and clear 5 to the x power, and then clear, and then graph. And then you can graph y is equal to 0.5 to the x power. You can see it changes. So the only thing I'm going to ask you to do here is algebraically, again, we're only talking about 20% of your test, okay, is be able to graph an exponential and to be able to do a couple of exponential laws, kind of like we did a while ago. Now, the 80% of your Chapter 5 test we're fixing to get into. Not going to get into it all today. Get into it back when you get back, all right? Because we only got one more section to go over after this, and that's solving systems of equations, I think, which I hardly ever get into. Y'all with me? Okay. All right, so let's look at logarithms, which is 5.3.
Yes.
The first thing they're going to start with is the definition of logarithm. Golly, look at there. And there it is. Now make sure you memorize this thing, because if you don't, you're going to be SOL on the test. And this is what you have to remember. You can go this way, or you can go this way. It all depends on what you're given. And I try to write, you know, when I'm given a problem, and let's say, we'll do an example here in a minute, but, and that's why I copied it. I copied it so I'd have it when I go to a problem. So let me just go to an example. All right, let's look at these three right here. And I'm going to take my handy dandy inserter and bring in, oh shoot, I can't bring them in. Okay, well, let me do this. Things I do for y'all. Snipping tool. Oops. No. And whiteboard. Right, I can't bring in that stuff on the transparency. All right, there's my definition of logarithm. And then bring in the problems. Okay, now one way the definition of logarithm works is to rewrite problems. There's two ways that you're going to use the definition of logarithm. To rewrite problems. The second thing you're going to use is to solve equations. Now you're not going to solve equations until like 5.4 or 5.5 or 5.6. So this is later. You're not going to worry about that right now. Right now you're just going to worry about it to write. So the first thing you're going to do is you're going to write the logarithm exactly like the definition. So y is equal to log base b of x gives us b to the y is equal to x. So I've got x is equal to log base 8 of 4. You see how I wrote it? I wrote it where it coincides with the definition. And then I go, okay, b is what? Y is what? And x is what? Now, if I wanted to solve this, one of the first things I would try to do is I would try to get some kind of 2 to the third power raised to the x is equal to 2 to the second power. You gotta get the same base. Why you gotta get the same base? Because if you get the same base, the exponents are equal. A lot of people don't realize that. They forget that, or they never have been shown that. I never forget when I was in college algebra, I was taught that, and I was like, I didn't know that. And I'd gone through 2 or 3 comprehensive studies. You all heard of comprehensive studies before? I'd been like through 3 or 4 classes of comprehensive studies, and I still didn't know that. I didn't learn it from high school, and I didn't learn it in comprehensive studies. But if the bases are the same, the exponents are what? Equal. So let's see what happens. Using the power rule here that y'all learned in 5.2, we reviewed over 5.2, that's 2 to the what? 3x, Hubert, is equal to 2 to the what? So what can I do with that 2 to the 3x? What can I do with that 3x and that 2? Set them equal to each other. Really? 3x is equal to 2. X is equal to what? 2/3. So I go back and I plug it in. My back is killing me for my people. That's why I'm riding this little cart up here. A little, what do you call them, jazzies? I'm going to get me a jazzy. 8 to the 2/3 is equal to 4. Now somebody take the calculator and raise 8 to the 2/3 power and see what you get. Well, exponent over index, that's the square root of 8 to the 3rd power. Well, what's 8? What's the square root of 8? You can't take the square root of 8. Well, what's 8 to the 3rd power? So it'll be 800. So that's equal to 4. So whatever how you want to do it, somebody take the calculator and tell me what 8 to the 2/3 power is.
It's just 1/3 is 2.
And 2, yeah, you could do that too. Let's take our handy dandy calculator. Eight to the 2/3 power It's a miracle. We did that in our head. We didn't even need a calculator. Definition of a logarithm. All right, you try the second one. You try B. While y'all are doing that, go right quick. 'Cause I know next week is what? And y'all are like bad out of Hades. Get out of here. I know. That's why I had to show up today. You know how it would have looked if I was sick the week before spring break? That would look kind of bad, wouldn't it? So I had to show up today. He's just being sick so you get 2 weeks off. Listen, I'm going to tell you something. Whatever I had, whether it was food poisoning or the flu, I don't know which one it was, it treated me like a rag doll. It was rough. Excluding the bad part, which is the first, 5 or 6 hours, we'll not talk about that. What's worse is after. I mean, your body feels like a cement block. You can't move because you ache all over. And you sleep for like 10 hours. So I think I had the flu. That's what I think. All right. Allison here. Barnes. Bearden. I thought Bearden was on Skype. I guess it's not. Cherry's on Skype. Clark. Chris. Driver's on Skype. Fields is on Skype. Fisher. Fox is on Skype. Fuller's on Skype. Harvell's here. Hull. Kemp. Kraft. Kunkel's on Skype. Silva's here. Simmons is not here. She's a loser. Strickland is on Skype. Warnick. And Weaver. Not here. Weaver usually Skypes in. He must be on vacation lately. All right. Which I can't fault him for that. All right, so now we got the log. Log base x of 16 is equal to 4. Log base x of 16 is equal to 4. You see how I did that? That's how you're supposed to do it. So what is b? The x to the 4th equals, hold on a minute, is equal to 16. And you really don't have to do anything here except take the 4th root here and the 4th root here, and x is equal to what? Check it. Put it up here. 2 to the 4th is equal to 16, and check it in your calculator. Y is equal to log base b of x. B to the y is equal to x. Log Base 4 of x is equal to 3 halves. 4 to the 3 halves is equal to what? And of course, you take whatever you need to there as the square root 4 to the third power, which is 4 to 64, and the square root of 64 is 8. Check that. Now, the other types of problems that you're going to do, and I'm just going to show you this right quick, in this section are going to be additive and, no, I'm just going to let y'all work on those. All right. That's it. I'm going to cut it off here, and y'all have a good break, and y'all can work on the homework here.